Hi Year 11s, this is Mr. Lim here, and we're going to go through today calculations, and we're going to be going through a topic of stoichiometry. Okay, so what is stoichiometry? It's the law of the idea is that the law of conservation of mass is why we balance equations to ensure that no atoms are created or destroyed. Okay, and so what we've learned before about the number of moles of stuff, so we know that a certain mass of something will contain a certain number of atoms. So when we balance an equation, what we are saying is that those atoms don't get created or destroyed, even in a chemical reaction, so that we can solve for how many particles there are or how many atoms there are of certain stuff when using the coefficient ratios of balanced equations to the ratio of moles of various substances in the equation. Now that's a lot of words, so let's go break that down. So the balancing of atoms, whoops. Okay, so the balancing of atoms will extend to the balancing of moles, since moles are just numbers of atoms, that we can apply to the coefficient ratios of balanced equations to the ratio of moles of various substances in an equation. What does that mean? So let's have a look here. I have one mole of that, which means I'm going to react with 2 moles of that. 1 mole of that will be produced, the CO2, and 2 moles of the H2O will be produced. All right. So what we have done is that through this balanced equation, we apply the coefficient ratios of that balanced equation, 1, 2, 1, 2, to the ratio of moles of various substances. 1 mole, 2 mole, 1 mole, 2 mole. All right. And that's kind of the idea of stoichiometry. So you can see here that it's what I've written. 1 mole of one molecule, so one individual molecule will react with 2 molecules to form 1 molecule of CO2 and 2 molecules of H2O. A dozen of those molecules, so we're just replacing the concept with a number of molecules, same thing. Therefore, 1.5 dozen molecules will react with 3 dozen molecules, and therefore 1 mole will react with 2 moles, and therefore I can pick any number, right? So here 4.68 moles of that will react with double the amount, 9.36, to form 4.68 and 9.36 moles of that H2O. Okay, so we're using the coefficients to help us work out the number of moles of various substances within a reaction in an equation. So let's just open up all of this. To determine the number of moles of a substance from another, we use the coefficient ratio to determine the unknown number of moles. This process is called stoichiometry. Okay, so what we're doing is we're using the number of moles of unknown equals the number of moles of known times the coefficient of the unknown and the coefficient of the known. So we go back to that equation. It was CH4 plus O2 goes to CO2 plus H2O. There was a 2 there and a 2 there. Right. So if I had 1.8 moles of CH4, right, I should be able to work out that I have 3.6 moles of that, because I know it's going to be double, okay, 1 to 2. However, not all the numbers are always simple, so we got to use what we know on this equation to kind of help us work it out when the molar ratios aren't so easy. So this one here was our known, so it was 1.8 moles of our known, right, is we times that by the coefficient of the unknown. Our unknown was this one here, so the coefficient of the unknown, 2, over the coefficient of the known, 1, which is over here, the lack thereof a coefficient there, it just says it's 1, so 1.8 times 2 over 1, which is just 3.6. Okay, so this equation just puts into it makes it a little bit simpler when the coefficients aren't so nice as 1 to 2. Okay, so let's have a look at some questions here. For the following reactions, balance their equations and answer the questions that follow. All right, so let's balance this equation. S8 plus O2 goes to SO2, so let's just add an 8 here for that SO2. That means I have 16 oxygens on that side, so I need to have 16 oxygens on that side, and there I have 8 there, so now I have there 8 and 1 there. Okay, so if 6 moles of S8 react with oxygen gas, determine the number of moles of SO2 produced. So what was our known? I can't remember what color I used. Green is going to be our known, 6 moles. That's our known. What's our unknown? Our unknown is the moles of SO2 produced. So the number of moles of our unknown will be equal to the number of moles of our known times the coefficient of the unknown over the coefficient of the known. Okay, so let's go fill out those things there. Right, what have we got? We don't know what the unknown is. We only know what the known is. The known is 6. We're going to times it by the coefficient of the unknown. The coefficient of... There. Let's just change all of these things so we can actually apply them to the thing. So what is our unknown? SO2. What's our... Sorry, SO2 there. What's our known? It's the S8. So we have the 6 moles of S8 times it by the coefficient of the SO2, which happens to be 8, over the coefficient of the S8, which happens to be 1. So 6 times 8 over 1 happens to be, what color should we make this? Blue. Should be 48 moles. Okay, so that's how that one works. Let's go do the next one. Let's just erase everything except for that balanced equation. Oh no, I'm gonna get bored of changing colors, so I'm just gonna do this all in black. All right, so the number of moles of, let's have a think. What's our known? What's our unknown? So the number of moles of known is, what's our known is our oxygen. So this is our known. What's our unknown? It's the SO2. So the number of moles of SO2 is equal to the number of moles of O2 times the coefficient of the unknown, which happens to be 8. Unknown, that's the SO2, that's that one there, the 8, all right, over the coefficient of the known, which happens to be the O2, which also happens to be 8. We fill out that as 5.3 times 8 on 8, which happens to be 5.3. And don't forget your units. I think I forgot the units on the last one. All right, 5.3 there. Okay, let's do that again. What's our known? What's our unknown? Okay, so this is our known, SO2. This is our unknown. Okay, so the number of moles of O2 is equal to the number of moles of SO2 times the coefficient of the unknown, which happens to be 8, over the coefficient of the known, which also happens to be 8. Oh, it's too easy. 6.4 times 8 on 8 is 6.4 moles. Okay, that's that one there. Those are those examples. Let's move on. No, I don't need to erase that. All right. So let's balance these ones out. Okay, so balance this equation. 5, 5. Oh no. Now I have 15 oxygens on this side, but I can't have 15 oxygens on that side, so I need to have a think. The coefficient of the water must be a multiple of 2, because I can only have 2 oxygens at a time, and since there's 1 in there, therefore this coefficient must be an even number. It also must be a ratio of 5, or a multiple of 5, because otherwise you can't balance out this one. So multiple of 2 and multiple of 5, lowest number is 10. That makes that one a 2, that one makes that a 10, that one makes that one a 15. Okay, so number of moles of O2 required to react with 4.3 moles of C5H10. Number of moles of O2, which is our unknown, required to react with 4.3 moles of C5H10. What's the molar ratio going to be? Okay, so what's our unknown? Our unknown is our O2, which happens to be 15. What's the known? It's our C5H10, so it's over 2. 15, 4.3 times 15 on 2 happens to be 32.25 moles. Okay, let's do that again. No, I'm going to be super lazy. Let's keep a whole bunch of stuff. Yeah. Okay, so what's our unknown this time? Our unknown is water. What's our known? CO2. What's the molar ratio between water and CO2? What's our unknown? Water, 10. CO2, 10. 1.2 times 10 on 10 is 1.2 moles. Easy. Okay. Then let's do it again. Number of moles of C5H10 required to make 10.8 moles of water. What's our unknown? C5H10. What's our known? Water. Okay, so even though we've made the water, it doesn't matter. It's our known still. Coefficient of the known, 10. Oh, nope, that's not right. Coefficient of the unknown over the top, 2 over 10. Right, 10.8 times 2 on 10 is 2.16 moles. Okay, so the number of moles is useful to determine the ratio between substances, but we are more used to working with mass in real life. Okay, thus we are often asked to solve for masses of reactants and products and chemicals other than from the masses of other chemicals. So in other words, we're not really going to be told, you have 1.6 moles of this inside this beaker, because really you have no idea how that goes. So it's just going to be the mass of that. We then must convert to moles first. This is super important. You can't do this stoichiometry without converting to moles. Then work out the stoichiometric ratio and amounts, and then convert back into mass. Okay, so what you're going is from mass to moles of our known to number of moles of our unknown, then back to the mass of our unknown. Okay, and that one's also known. So we're going to follow these steps. Mass of our known goes to moles of our known, turns to the number of moles of our unknown, and then to the mass of our unknown. So let's have a look here. For following recursions, blah, 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 balance the equation. Okay, so balancing equation, 2, 21, 14, and 14. All right. So once you've balanced that equation, we have to look. 27 grams of pentene is burnt in oxygen. Determine the mass of carbon dioxide produced. So what's our known? This pentene. What's our unknown? Carbon dioxide. Okay, we have no idea how much carbon dioxide we're going to produce, but we've got 27 grams of pentene to start with. So we have to work out the number of moles of this C7H10 to start. Okay, number of moles of C7H10 will be equal to the mass of it, 27, over its molar mass, which happens to be 98.182, which will equal to 0.275 mole. Right, once I've got the number of moles of that, I can work out the number of moles of CO2. So this is the things that we've been doing for the last however many minutes. Equals number of moles of C7H14. Oops, not H14. Yes, H14. H14 times, what's the stoichiometric ratio? Okay, so what's the coefficient of our unknown? 14 over our coefficient of our known, 2, which happens to be 0.275 times 14 on 2, which happens to be 1.92 mole. Okay, then finally we can work out the mass of carbon dioxide, which will be equal to the number of moles times molar mass, which will be 1.92 times 44.01, which happens to be 84.72 grams. Okay, so that's what you do. This is mass to moles. This is moles to moles, and this is moles to mass. Okay, let's do that again. Let's keep most of this. Mr. Lim, you're so lazy. Okay, and so let's look at the next one. If 51 grams of water is produced from the combustion of pentene in oxygen, determine the mass of oxygen consumed. Okay, so what's our known? Our known is the water. What's our unknown? Oxygen. Okay, so the number of moles of water is what we're going to start with of our known, 51 over 18.016, which happens to be 2.83 moles. Then I need to work out the number of moles of my oxygen from my water, right, which will happen to be 2.83. Nope, whoops, no, that's not right. What's the molar ratio there? Right, so that is oxygen to water. Oxygen is 21, water is 14, so it'll be 2.83 times 21 over 14, which happens to be 4.25 moles. Right, then I got my mass of oxygen, which will be equal to 4.25 moles times the molar mass of 32, which happens to be 13588 grams. Okay, so that concept of mass to moles, and moles to mass, super important. We're going to be practicing that lots. These two questions here are a little bit more difficult. I'll let you have a go at them, and if you think that you can do it, then you should send me a message. If you can't, then that's okay. It's not too bad. All right, that's all. Send us a message if you don't understand what's going on, and do all the worksheets that we tell you to do. Adios.